than the default. My question right now is, I repeat because I just started recording, is what's the hottest planet in the solar system? You'd say Mercury. Anyone else have any better guesses? I can understand why you'd say Mercury. Coolest, before next question, I wasn't going to ask. Amanda, you should DM, not DM, but do group chat because you're replying. Ira, what do you think? Mercury, is everyone okay with Mercury being the answer?
Subse hottest?
The hottest planet, yes.
Yeah.
Mercury, right? Like that makes complete sense. And I come along, being as smart as I am, and tell you it's Venus, for sure. No jokes. Venus is the hottest planet in the solar system. Can anyone guess why? Or like, and I'll share this interesting diagram with you, which I saw on the interweb. Here are the relative temperatures of all the planets. So ignore the left-hand side where they're talking about Fahrenheit. On the right-hand side, they're talking about Celsius, right? And here is Venus at close to 450 degrees, I think. I'm not reading it exactly. Sorry, 450, how do you write it? 450 degrees Celsius. Then Mercury at, what is this? Okay, four higher than 480 or 470 something. Mercury is at 430, I'm guessing. And all the way you have Earth, the third hottest planet in the solar system, which makes sense, is at 22, I'm guessing, degrees Celsius, the average temperature. Okay. Is this a complete oddity? Venus being the hottest planet in the solar system? Thumbs up if you guys agree. Can anyone guess why this is the case before I move on to answering?
Venus is closer to the sun.
Audio is very low. I think someone's answering, but audio is very low. Someone answered, but audio was really low. Try one more time. And if not, I'll just continue. Anyone? No? Okay. Aman's saying something. He's saying trapped greenhouse gases. I think that's what I think Soha was talking, and that's what she said, or something close to. It's not close to the sun. No? Venus is the second planet, if you notice. It's, well, the closer to the sun, this should have been the hottest planet, right? The hottest planet is actually Venus. This is the second planet from the solar system, whereas Mercury is the first planet from the solar system. But Mercury is actually cooler than Venus, which would make you think, oh, maybe they're very close to each other, and for some reason Venus is, no, they're not too close. They're like, Venus is twice the distance from the sun, and like as Mercury. And yeah, like it's still really hot. And the reason is greenhouse gases. Greenhouse gases. Okay, let's talk about what greenhouse gases are. You guys know what a greenhouse is? Thumbs up if you guys agree. Thumbs down if you guys don't know what a greenhouse is.
Okay.
Yeah, greenhouse, you guys know? I'll tell you what a greenhouse is. This is a greenhouse. पता नहीं? Oh, okay, that's not a greenhouse, that's a thermometer.
So वो होता है ना just sunlight की दूसरी type of waves में convert हो जाती है, वो escape नहीं कर पाती.
I think you're on the right track. I think you know what you're talking about, but uska exact reasoning nahi pata. And I'll tell you what it is. This is a greenhouse. It's called a greenhouse because it's essentially made from glass, right? And uske andar plants normally rakhte hain. That's why you keep it like that. So it's just called a greenhouse. Okay, because you want sunlight. Not just that. And the reason for this is you can probably guess from this picture because there's a snowman here. In climates where you want to grow plants, where the climate is too cold, you make a greenhouse. What ends up happening is, how this works is, it's a very physical phenomenon. There's nothing about gases over here for now. What ends up happening is, let's say 100%, like sun is shining on this city or wherever this is, on this greenhouse at its capacity of 100%, right? That's what it would do because nothing's hindering it. That light would be stopped by the greenhouse just a bit, because glass may, even though it's transparent, थोड़ी reflective layer होती है, because you can see, reflection out of the glass paper, even though it's transparent. So let's say 80% of the light is allowed through and 20% is reflected out. Just for example, that 80%, once it touches these plants, the remainder of that light would be, reflected back on the inside of the glass, which does the same thing. 80% of that light gets thrown back in there and 20% gets to leave. And ho kya rehta hai? It just keeps happening for a while until the light is too weak and it just eventually leaves. But what ends up happening is the area on the inside of the glass gets way warmer than the outside of the glass. You guys agree so far? Infrared waves are trapped. Well, essentially from sunlight, we don't care exactly what is trapped, but essentially all of sunlight is trapped. And infrared, you say, or you've read that, because infrared is the light you cannot see, but this is carrying majority of the heat energy from the sun. So when you say infrared, you just mean, my camera's on, I should just turn it off, because I'm not using it. Okay, any questions so far? A good time to ask any questions. If this makes sense, let me know. If this, no problem, Fatma. We're doing global warming. Welcome. Okay, does this make sense so far or no? Just show me thumbs up or thumbs down, like in the, Aisha gets it. Aya is getting it. Fatma just walked in. Ahmed doesn't get it, I think. Most people get it. Atika, are you getting it or no? Okay, most people get it. I don't think there's a question. Fatma, I'll just reiterate one more time, is we're talking about what a greenhouse is. This is called a greenhouse, not because it's green in color, but you grow vegetables and like greenery in it. So it's a house for, and the reason for this is in a very cold climate. So we're small. Okay. In a very cold climate, some plants cannot grow. So you develop these greenhouses so the sun's heat gets trapped in the house a lot. And that happens because the glass is able to contain the heat, right? And if you guys are looking for example you experience every day, you know that when there is a car out in the sun for too long, you've noticed and you felt that the car is way hotter on the inside, than on the outside. And this essentially happens because, again, of the same greenhouse. I was trying to draw a shisha over here. The sun rays do the exact same thing. It happens much less. It happens much less than a regular greenhouse would allow, because most of the car is not glass, only a small percentages, but it does heat up. So on an average day where the temperature on the outside is, let's say 35 degrees, the car can go up to 45 degrees if the car is black and everything, right? Do you guys know why black will get hot a lot more than a car that is white, especially if the interior is white? Do you guys know about that? A black car gets significantly way hotter than a white car, up to 10 degrees difference on a hot day. A white car would be 10 degrees cooler than a black car if it's left in the sun. Do you guys know why? That's a physics radiation question.
absorb
करती है ना ज़्यादा.
Black absorbs a lot more than white. It absorbs a lot more energy, so it increases the temperature of the car a lot more. So white cars with white interiors would be a lot more cooler, and people in hot climates prefer. Exactly, Fatma even said that. Okay, all right. And this essentially is the greenhouse effect. The car being hot on the inside. You've experienced it every day. Okay. Everything understood about greenhouse? What a greenhouse is? Yes? Thumbs up if you guys get it. Now, so far, it's a very physical phenomena. It's a very physics-related phenomena, nothing to do with chemistry. Okay. And what happens? So here's an exaggerated diagram of our planet with its atmosphere. The atmosphere is not this thick, but it's exaggerated just to make a point. And what happens is this atmosphere is translucent, it's transparent, it's a coating on the planet, right? And what ends up happening is this ends up behaving very physically to how glass behaves, because it's very similar, like optics wise, or like if you try to look at this problem, it's just a bubble of gas surrounding the planet where there's nothing around the source, like from between the sun and the earth, there's nothing aside from this little shield, transparent shield that's surrounding the planet, right? And what ends up happening is the same effect ends up happening. A greenhouse effect happens. Greenhouse effect. That's where the word comes from a greenhouse. This effect happens because some of the light is reflected, but the light that passes through gets trapped and keeps oscillating between the atmosphere, diminishing, and keeps getting reabsorbed over and over again, causing a greenhouse effect, and that just warms up the planet. And this was always happening. This is nothing new, right? But recently, in recent times, what's happened is the capacity of the atmosphere to retain heat has increased because the atmosphere has changed. Why has the atmosphere changed? There is a lot of carbon dioxide than before in our planet or in our atmosphere, and a lot more methane gas in our atmosphere. Now, both of these gases were naturally present in our atmosphere. But again, there's a lot more of them. Okay? And this changes the texture or the ability of the atmosphere to retain heat. It increases it quite a bit, right? And if it's increasing it, the planet is warming than how much it should be, right? With me so far? Any questions so far?
No.
Aisha agrees? No? Okay. Soha, what do you think? Is this making sense so far?
Yes, sir.
Okay, brilliant. And we have Fatima. Yes, sir. I think that was an older yes, sir. Ashwin, how about you? Where are Brandon and Hayden? They haven't showed up to one class. Does anyone know? Ahmed, any questions so far?
I think that they have internet issues.
Okay, okay. I'll try to share this with them. Yeah, okay. Okay. Everyone I feel are getting it. I also hope everyone finds this interesting. It's not the most interesting thing in the world, but if you're more, the more you know about this, the more environmentally, I don't want to say woke again, but I don't have a better word, so the more environmentally woke you can be about planet issues we're facing in the 21st century. Okay. Now this is why, can someone tell me why this is really bad? Why is this bad? Why is this bad? If the planet is heating up, why is that a problem?
Can you repeat the question?
My question is, if the planet is heating up, and it's not heating by a lot, it's heating by, let's say, 2 to 5 degrees in its average temperature. So
Can cause a
why
lot
is
of
this bad?
change.
Hmm?
It causes a lot of climate change and geographical changes.
All right. So
And
climate change.
ozone level are destroyed.
Climate changes. I heard something else, which didn't make too much sense. What else? Snow melting. What else? Glaciers, ice caps, etc. Or we'll begin, but like you can argue, hey, why is glaciers melting a bad thing? But okay, let's talk about why it's causing a climate change. Climate change is mostly around the principles of convection. If I have the planet here, let me try drawing our planet. Of course, it'll be drawn in blue. Here's it's not a continent. Australia, here's some other planet, and here's some other continent. I said planet earlier, I meant continent. Okay. Now what's happening is, let's say the line, this is the equator. Like that, I'm drawing it at the same angle how I saw this particular image. And the sun is over here, so the sun is not green, the sun is yellow, and it's shining. So what generally happens even before global warming is, this region in the center is heated up the most. And because of convection, because the gases are heated up a lot more, gases by I mean air, the atmosphere is heated a lot more. The trend of climate is kind of like that. Air kind of goes towards the upper areas, or that's how wind flows. And all of these air currents have a specific pattern. They change yearly because they're very used to a certain pattern, because the sun heats up the upper atmosphere, the northern hemisphere, a lot more in summertime, and the southern hemisphere a lot more when it's winter time. So they have a very specific pattern. So this pattern highlights where the rain clouds will go, and it more or less highlights how the seasons work, right? Because why is it raining in June and July every time in Karachi? Because that's when the wind is carrying the rain clouds exactly over Karachi towards India. And that's why we get like rain during that exact month, more or less. And not only that, our entire irrigation system, this has been happening for 1 million years. Our entire irrigation system, or like plants, have evolved to expect water in summertime, right? And expect that much heat in summertime, everything. And when something causes a disruption to this temperature, this heat is being reduced, this wind directions are being changed. Not that we'd be affected too much by it, because like wind is wind to us, like hawa chal rahi hoti, it's good. But these clouds are not going in the same places anymore. They're going somewhere where they would never show up. So those same plants that in Karachi, let's say, which are expecting rainfall, do not get that rainfall. And of course, we can supply them with water if it's a pot or two, but massive lands where there's a lot of like rainforests and everything, if they're not expecting the right amount of rain, they will all die. So this is one huge impact to ecosystems. And if rainforests die, any life depending on that rainforest will die as well. And you can look at you can expect mass extinctions, and which has probably even started right now, of that life, because we can only do so much to control nature. A lot of nature we don't control, like forests generally we don't control, and this is causing to that effect. Okay. All of that said, do you guys follow so far?
Yes.
Solid, more. Okay.
Yes.
Okay. So is this interesting, or is it like what's he
That
talking
this
about?
is basically geography.
It's basically geography. Are you guys familiar with all of this? What I'm talking about?
Almost, yes, almost.
Almost, man, your geography teacher was really good. Okay, fine, fair enough. Okay. Okay, so I'll skip ahead now.
No, no, it's
How does?
fine. What if I don't
Hmm?
remember?
Yeah.
I don't trust my knowledge. What if I don't remember any of this?
Most of this is not really like a very small paragraph is, I could really share a very small paragraph with you right now, which talks about how chemically global warming is taking place. And we could read that and kind of ratify it and we could be done with it. But all of that needs to fit into place if you guys want to be educated on the subject and kind of do what the syllabus wants us to do. Okay. Acha, one more thing is, I'll just continue because I want to wrap this up real quick. I'll be fast rather than be, less descriptive. One thing is a positive feedback loop. And a positive feedback loop is for things that affect, like the result affects the input in a certain way where it increases the result even more, right? And one such example is, let's say this is me, and I eat a certain amount of food, and I exercise a certain amount, right? Now, if I stop exercising for a few days, if I get busy, like these days I'm not exercising, so what's gonna happen is I'm gonna get fat, ever so slightly fat. Now, what's gonna happen is if I get fat, I'm heavier essentially and slightly more unhealthy, and I'll feel more tired because I'm heavier and weaker. I'll feel more tired when I'm exercising, so I'll be less incentivized to exercise, right? And if I'm exercising less, I'll get even more fat and fat and fat and fat. And if I'm not aware of this loop, this positive loop, like where I feel more tired about exercising, so I get fat more. And if I'm getting more fat, I'll get more tired about exercising and I'll just become very unhealthy until, something bad happens to me. So that is an example of feedback loop, right? And let me go back to highlight another feedback loop that happens on our climate change. The global warming, which is happening, is also a positive feedback loop. Positive implies that it keeps on increasing. A negative feedback loop would decrease the result, but we're not talking about that. How so, you may ask? Is global warming a positive feedback loop? Let's say global warming happened because of a bit of carbon dioxide in the air. One thing what happens is if the average temperature of the Earth rises, the polar ice caps will melt ever so slightly. Let's say pehle itna the to itne ho gaye. Or let me just highlight itne this part melted and this is what's behind. Now the polar ice caps do one thing is that they help reflect the light back to the sun. And that's happening less because, well, they're white and now this area is not white anymore, it's just dark blue ocean, right? So the planet's capacity to reflect light has decreased because of the global warming, and that increases the temperature even more, which will decrease the polar ice caps a lot more, which is decreasing the Earth's capacity to, reflect light even more over and over again until all of the polar ice caps, for one thing, are gone. Does this make sense? Did you guys know that earlier?
Yes, sir.
Okay, everyone knows this. Okay, the other thing is that all of this rising, the ice caps will melt, increasing the amount of water in the ocean, which will lead to rising sea levels. If the sea levels are rising, this would, like on some parts of the world, destroy a lot of life, plant life especially. And that life, once killed, would rot, like dead plant, what's the word for it? Dead plant material, I guess, would produce a lot of CH4 and even carbon dioxide, which would go into the atmosphere and increase the atmosphere's capacity to, retain heat, which would heat up the planet even more and cause more destruction. Okay. Have you guys seen that documentary by Al Gore about global warming? Have you guys heard of it? No? Global warming.
No.
I forget the name, but that was a very scary and interesting documentary about global warming, essentially talking about this stuff in a much more refined manner. Al Gore was the vice president of the United States like some 20 odd years ago. Okay. Okay, this is all more or less understood. So how can we reduce global warming? How can we minimize global warming? So one direct cause of global warming, if you're looking through it through the chemistry lens, is carbon dioxide and methane. Now, methane, I'll just be upfront, is that you can't do too much about, and we're not really producing too much methane anyway. The issue is that we're producing a lot of carbon dioxide, which is causing all of this. Let me share a graph with you, which talks about the average amount of carbon dioxide on the planet. Here's the graph. This is the industrial revolution. Before this, it was way less. And industrial revolution started increasing, factories started showing up, and it's going insane. And this is probably a very, what's the word for it? A very humble graph. It's actually like that. It's shooting up the amount of carbon dioxide. Okay. And again, more carbon dioxide leads to the planet warming up, which will produce more carbon dioxide. So how can we fix this problem which we're facing, which is global warming? Any suggestions? Either we can reduce, essentially we have to reduce the carbon dioxide in our atmosphere. Either we can do that by collecting it from the atmosphere and reducing it, or producing less of it. So let's talk about the first one. How can we collect carbon dioxide from the atmosphere and reduce it? Now think about this in a global manner, because you can't really just go out in a plane and collect carbon dioxide in a net, right? Or do some, like, it's a gas all over the place, and it's in very small quantities, because it's like 1% of the atmosphere. We need some, there was a catalyst for this, and you forget the name. Do tell, I do want to know about this catalyst. I shall ask Ira. Ira, what do you think?
Question repeat करें sir?
मेरा question है, how can we reduce the amount of carbon dioxide in the atmosphere?
Plants उगा के.
Yes, that's the best way. If there are more plants, they'll consume the carbon dioxide and replace it with oxygen. And that's more or less the only way to do it. And there's no chemical process involved. It's just, we got to minimize the amount of carbon dioxide in the atmosphere. And the best way to do that is increase the number of plants on the planet. So they'll counteract the amount of carbon dioxide there is. Actually, we're also, deforestation also leads to a huge increase in carbon dioxide, because we were already producing a lot of carbon dioxide, because every living thing on the planet lives and breathes, right? So they exhale carbon dioxide, but that was counteracted by the number of plants on the planet. They would absorb the carbon dioxide and produce carbon. So it was a balance. And that balance has been also been destroyed because we just use up a lot of wood and don't plant it enough. So deforestation is an issue. Okay, how do we produce less? How do we produce? Why do you think we're producing a lot of carbon dioxide? What chemical process produces a lot of carbon dioxide? Respiration does produce it, but it's not, respiration was always there. Fatma has the answer, combustion. Combustion happens because of cars. You can imagine how many cars there are, factories, industries, you know, even our approach to counteracting pollution results in a lot of carbon dioxide, because what we do is we take all of the waste product and we incinerate them to produce energy and whatnot, and just burning them just produces a lot of, what do you call it? Carbon dioxide. How can we minimize the production of carbon dioxide? What can we do? There was a biological catalyst to reduce carbon dioxide, maybe in plants, some enzyme, I don't know. Maybe there is something. Let me just Google it. By the way, I got into a huge debate with Abdullah. He was furious because he found out about, Ahmed would know this, negative catalysts, which, so he was very upset about that idea because he argued that there was no such thing as a negative catalyst because there's another word for them, and huge, like he was very upset about it. That there's in academic literature, there's a thing called negative catalyst. Ahmed, you might be interested in that. Public transport over personal cars, absolutely. But let me try to Google biological catalyst for carbon dioxide. Biocatalyst for the application of feedstock. Some enzyme, protein synthesis. Can't think of any. Doesn't really look like nothing. So well, let me know if you find out. For now, nothing specific, nothing's showing up. Like it's not part of pop culture at least. Okay, back to this. So public transport is great because if you use public transport, that means less car on the road. So you're being more economically friendly. Less cars on the road means less carbon dioxide produced. Less carbon dioxide produced is healthier planet. Okay. Recycling is also a really good choice if you actually, instead of recycling, because that also involves a lot of carbon thing. Instead of recycling, reusing is much better. Reusing produces no waste. And I'll tell you why recycling is bad. Also, it's a lesser of evils. It's not a good thing. Recycling is if you have a shopping bag and you throw it to a recycling center, someone has to first carry it to a recycling center, you know, let me draw the arrow of a recycling thing, where it gets heated and melted and reproduced into another polythene bag. I'm trying to make a polythene bag with a very awkward angle, right? And that transportation and heating is producing carbon dioxide. So some people argue you're producing more carbon dioxide than just let it burn and just produce, you know, more polythene bags from fossil fuels. So you'll probably produce less. That's why also recycled polythene bags are actually more expensive because you're wasting a lot of carbon just recycling them. Here was someone answered in my online tutorial. Someone said, if you use an electrical car, that's actually really good for the environment. What do you guys think? Is this good or is this bad?
Car with batteries.
Car with batteries? A Tesla.
Yes. But
Yes, that's a
पाकिस्तान के हालात टेस्ला वाले नहीं है.
हाँ, दोबारा बोला?
पाकिस्तान के हालात टेस्ला वाले नहीं है.
हाँ, पाकिस्तान के हालात, हाँ, वो तो दूर तक हम तो like phone भी हमारा मुश्किल से सही चल रहा था. We had the internet, which was like 15 years ago. in other countries or coverage था ही नहीं. Oh well.
टेस्ला खराब हो जाएगी. आपको स्पीड ब्रेकर्स देखे? It feels like we are going up a hill.
हाँ, what? क्या?
सर आपने पाकिस्तान या कराची के स्पीड ब्रेकर्स देखे हैं? ऐसा लगता है कि हमने we are going up a hill and going down a hill.
Yeah, those are actually good because the other ones destroy your car. The tiny ones, like वो जो झटका पड़ता है, you know, like it's like the upper hill ones are actually much better. Don't like, I don't know, but like depends again. Like relative to this car, I think इतने ऐसे speed breakers होने चाहिए because that would really make you slow your car down. And if your car is slow enough, it just glides over it, so it feels like you're going up a hill. That's much better than that annoying this one. जितना भी slow कर लो, आपकी गाड़ी टूटने वाली है, and it just, you know, I have neck issues, so I personally hate these ones. That's my 2 cents. But here's a question: even if you're in New York or anywhere, people are arguing a Tesla is actually just as bad as a regular car. Can you guys tell me why? Why is this person saying it? Why do smart people say a Tesla is just as bad as a normal car? Here's a normal car in comparison. Clearly, I was born an artist. What do you guys think? I have a feeling Ira has something to say about this, which will be on the right. Ira has something to say about this, which will be on the right track.
Ira is busy laughing.
Huh?
Ira is busy laughing.
Sir, किस बारे में?
Why is she? Ira, why are you busy laughing? Lol.
सर वो सोहा जो है ना वो पागल है एक्चुअली.
Sorry, क्या आवाज कट रही है? दोबारा बोलें.
क्वेश्चन क्या है मेरे लिए?
पहले ये क्वेश्चन ये है, आप इतना हंस क्यों रही हैं? Why is Ira busy laughing?
सर वो सोहा की वजह से, उसको छोड़े. क्वेश्चन बताएं.
Okay, fine. So like, I can't get to know, or is it like a private thing? Voice is
Sir,
very
mix.
Which mix? Can you guys type because आवाज कट रही है? I don't know.
She's laughing on the hill. वो वाली बात पे we're going up a hill and down a hill, nothing else.
Fair enough. Okay, fine. ठीक है, okay. अच्छा, a Tesla is actually just as bad for a normal car. Now, I don't know this, but here's the argument, and you guys can do your own research and actually decide on your own if it's actually really bad. A Tesla runs on completely clean energy, produces no waste products because it runs on electricity. It has 0 waste products. That doesn't mean it doesn't impact the environment in a negative way. This is called a carbon footprint. A carbon footprint is literally how much carbon you produce. Like as you move along, production error, I don't know what that means. This car produces a lot of pollution, but that's not the only cost. This car is manufactured in industries because the metal has to be made and tires need to be made, you know. Tires तो rubber के बनते हैं ना. Rubber के tires कहाँ से आते हैं? Rubber is a form of plastic. Plastic कहाँ से आता है? Fossil fuels से. So this is not as green as people would like you to believe. And it's not because of the tires. One major issue is, how is electricity produced? Well, electricity is produced, 50% of all electricity, or majority globally, is produced by fossil fuels. And electricity में एक मसला है, if it's produced at a factory, F-A-C-T, fine, fact. If it's produced at a factory, by the time that electricity goes through power stations everywhere and ends up reaching the car and charges the car, that electricity has suffered losses by 30% at least. So transferring of electricity is not efficient. So a lot of coal has been burned to get electricity into your car, right? And again, if you drive it more, replacing parts of it, whatever, or everything, like an iPhone has a carbon footprint. They're produced because parts need to be extracted and heated and melted and soldered and batteries needs to be made and screens need to be made, all of those things. Like they can argue like a person from it's probably close to a person living 10 years of their life produces the same amount of carbon dioxide as a manufactured iPhone, one iPhone. I'm sure those words, like you can change the stats. It's very hard to follow these things in real life. So these are just for like an idea, but everything being made is producing carbon dioxide. And we refer to this concept as a carbon footprint. So what do you guys think? Is a Tesla more eco-friendly or less eco-friendly?
Eco-friendly, I think.
You guys still think it's eco-friendly? I think it's still eco-friendly. Yeah. But if this is 100% of the damage, this is probably 70% damaging the atmosphere. It's not like this is zero.
It's a normal car.
Huh?
It's more eco-friendly than a normal car.
Definitely, it beats our buses and rickshaws any day because they're just throwing carbon out, you know? So yeah, definitely. Okay, what time is it? 3:48? Yeah. Okay. Another talk about not global warming per se, but global issue is, let me bring that diagram back out. And I think we're putting a full stop in thinking about the planet. We're going to talk a bit about ozone. Now, do you guys study ozone in geography?
Yes.
The ozone layer, huh?
Yes.
Yes or yes? Okay. So ozone is O3. It's relatively kind of unstable, an unstable gas. And it's formed when oxygen is exposed to ultraviolet light and it turns into ozone. So ozone turns back to oxygen if it's not exposed to UV light anymore. Okay. Now, much like any reactions in equilibrium, why did I write it like that? Let me write it properly as a chemical equation. Oxygen can turn into ozone. And this is actually a backward reaction. And if I had to balance it, I would put 3 oxygen molecules will turn into 2 ozone molecules. People find this balanced equation very confusing because they think, how could 3 molecules of oxygen turn into 2 molecules of ozone? 3 turning into 2, it does not make sense. But if you give it some extra thought and count the atoms, it will make a lot more sense. Because moles, end of the day. Okay. Now, the ideal place for the ozone to form, or the exact conditions in our atmosphere, because it needs like low pressure, I don't exactly know what it needs, but apart from most things, it needs a lot of UV light to form. And the best place for it is in the stratosphere. The stratosphere is I don't know what layer of the atmosphere it is, but somewhere far from the planet. It's actually a very thick layer, and it's way above where you have your jets flying. So jets would be flying here. Ozone is much higher. And the atmosphere's oxygen is actually reacting and turning into O3 because the sun is providing a lot of UV light. And that UV O3 is turning into, sorry, that O3 is also turns into O2 back to O2 when it goes down away from that sun, because again, this reaction is in equilibrium. So there's this more or less equilibrium of gases, ozone being formed. And as soon as it leaves away from the top layer of the atmosphere, it turns back into oxygen. Okay. So essentially there's a layer of ozone surrounding the planet. And because this reaction requires a lot of UV light, it's essentially absorbing most of the UV light from the sun. UV light is very harmful for life on the planet. The ozone layer has been more or less been there for majority of living life on Earth. Now, some people also argue that the life originated under the sea and not on land, because under sea the conditions were more ideal. And one of the reasons conditions were ideal were that the planet was majority covered by carbon dioxide and there was very little oxygen. If there was very little oxygen, there was very little ozone. Because of that, the entire surface of the Earth was being sprayed by UV light, very dangerous radiation for life. So it was a very hostile environment on the planet. As soon as a lot of plant life grew underwater, over time, they covered majority of the land that is underwater. That ended up producing a lot of oxygen, and all that oxygen started covering the atmosphere, producing a lot of ozone, shielding the planet from the ultraviolet rays, and allowing life to grow, plants to grow on land, right? Does this make sense? I did go, I can Wi-Fi ka masla hai. Cannot hear me again still? I'm sorry. I didn't see this message for the longest time. Did you guys? Okay, so I can. Okay. Fatma, did you follow? I hope you did. Okay, ठीक है, चलो great. ठीक है. Now ozone is really important. Now there's one other reaction you guys see where the condition is UV light. There's a very specific reason the syllabus is highlighting that UV light is used. Can you guys remember that reaction? I'll give you a hint. It's one of the first organic reactions you studied. What is the name of that reaction that has a condition? Addition reaction? Oh, you're close.
Condensation.
Condensation? No, not really. That's your polymer vagara, no? It's your substitution reaction. Substitution, but this probably makes people think of absolutely nothing because substitution is a very generic term. But which substitution reaction am I talking about? When an alkane is able to react with chlorine to form a chloroalkane, right? Let's just call it chloroalkane. Chloroalkane. And the reason for this is any alkanes can undergo substitution reaction. I could have drawn even methane right now if I wanted to. I was just exercising my organic drawing skills. And this would turn into a chloroalkane. And also end up producing HCl. Because why is this a substitution reaction? The UV light, which is the condition for this reaction, some bonds are sensitive to these this ultraviolet radiation. That's also why it's so bad for us, because when we get hit by it, those certain bonds break, much like oxygen is able to break and oxygen के atoms घूम रहे होते हैं, वो एक और oxygen के molecule में टकरा जाते हैं, and the conditions are just right to turn it into O3, which is again very unstable. ठीक है, ये बार बार बन रहा होता है. यहाँ पे क्या होता है? UV light hits the chlorine atom, turning it chlorine molecule, sorry, and turns it into a chlorine atom. This chlorine atom being very reactive, because it's a very reactive, atom, takes the place of a hydrogen by, displacing it or substituting it, and turns that molecule into a chloroalkane. And the other hydrogen that got ejected bonds to the chlorine that is present. Okay, this was one of the first reactions we did. And this reaction happens a lot in the atmosphere by a particular molecule that has chlorine attached to it and fluorine attached to it. This particular molecule was allowed to escape into the atmosphere a lot because industrially, this particular molecule was very important. It was known as a chlorofluorocarbon, or CFCs for short. These gases were used as cooling gases, जो gas आपके AC और fridge में जाती है ना, and ACs and fridge were drastically being produced around 1940s, and they still are, because everyone depends on them right now, because that's our one way of storing food. So a lot of this gas was being produced, and जब भी हमें इस gas को जरूरत नहीं होती थी, this gas would be released into the atmosphere because it was more or less harmless, or so we thought. It wasn't harmless. When it would go to the higher levels of the atmosphere, it would undergo a reaction in which UV light would take the chlorine out of it, and there was a chlorine molecule. A chlorine atom was produced in the upper layers of the atmosphere. Which upper layer? The stratosphere, where the ozone is undergoing that reversible reaction with oxygen. And it would come in the way and disrupt this reaction and form OCl, or I don't know what exact molecule they formed. I think OCl2 or something like that. And this gas would just be a little more stable and just float away. Now, this would reduce the amount of oxygen present and the amount of ozone present in the atmosphere, because it's all turning into OCl. But oxygen being 20% of the atmosphere, koi masla nahi hua. But ozone was not a lot. It only covered a thin layer of the outer atmosphere, started depleting. And because it started depleting, that area was void of ozone. Those areas void of the ozone were known as holes in the ozone layer. And because there were complete gaps, this area would not shield the area over here from the UV radiation. The UV radiation would just enter and wreak havoc over that layer. Good thing is the two largest ozone holes that were made primarily on Antarctica, so we were safe. Otherwise, cancer would be a lot more popular, I guess, in our society if it happened in a very populated area. But good thing is people reacted very quickly, stopped the production of CFCs and replaced them with HFCs, not the other way, HFCs, which are hydrofluorocarbons. So it doesn't have that chlorine molecule or atom in it that causes all those problems to the ozone. And it's been 20 years and we keep hearing about the ozone layer shrinking. So it's been 20 years since the amount of CFCs that have been, we've stopped producing it, but the ozone layer will take its due time and heal and shrink. It's still shrinking, and I don't know what's going to happen, but yeah, over time, eventually it should decrease and we should have our ozone layer completely back. Chlorine atoms cause depletion of the ozone layer, allowing radiation from specks to enter into atmosphere. Yes, I was just reading what Fatma said. Does this make sense to people? Ozone layer, ozone issues,
Yes.
Chemically how they're involved. Okay, TK. We'll continue this and I'll let you know what our schedule is, but we'll have some class around Tuesday or Wednesday at 3 p.m. TK. Is that okay?
Thank you, sir.
Fatma, go ahead, ask your question. If anyone wants to drop out, they can. Thank you for waiting for an hour. Bye-bye, guys. Take care. Fatma, you can ask your question.
Thank you.
Bye, guys. Atika, you were there all this time? They're allowing students to opt for Chem ATP. Okay. Okay, Atika, bye-bye. Did you enjoy the lecture, Atika, before you leave? But okay, Fatma, you go ahead. We're not opting for the ATP. Actually, we're not too sure exactly kya ho raha hai, because Cambridge has been very busy because it got British Council, Pakistani British Council. They're busy. Okay, like nice. Thank you, Atika. All right. We went for an exemption, Fatima. So we're exempted from P4. So we'll just focus on P1. And I think, honestly, that's a good choice. And I'll tell you what, will they fail us overall? Yeah, but don't worry about MCQs. We'll improve our MCQ capacity because, here's how I see it. P4s are generally smaller, easier than P1s. But the issue with P4 and also P2 is our class, because of Corona and everything, has spent very little time going over how to answer P2 questions, and P4 तो हमने touch ही नहीं किया. ठीक है? P4 takes about a month to understand and how to do well. हमारे पास एक महीना तो आराम से है, but most of that time is spent very busy because your exams are around the corner and everyone's studying. Now, P2 cancel हो गए, that's really good for everyone because इसमें सबसे ज़्यादा improvement time चाहिए improve करने के लिए. P1 सबसे आसानी से improve हो सकता है और P2 सबसे late भी हैं. तो this is great. P4, even though you're not taking it, and it's a very scoring exam, everyone has very little exposure to P4 this year around because no student has walked into a lab in the last 2 years. Okay? So if you don't know, if you haven't seen most experiments, you'll be naturally be less able to score well in a P4 paper. Again, wo percentile वगैरह होती है. But again, all your eggs are in one basket right now. But that's on the off chance your P1 paper will go poorly. Your P1 paper will not go poorly because P1 is generally straightforward, right? And we'll have 2 months of non-stop practice of P1 के questions. हमें सब answer याद होंगे, right? अगर हम 2 महीने सिर्फ P1 करते रहे. ठीक है? So our likelihood, so I understand कि it's all on this paper. अगर हमारा P1 बुरा हुआ तो हमारा एग्जाम का ग्रेड बहुत बुरी तरीके से गिर सकता है. But our probability of P1 going bad is decreasing. Let's say 75% आपका पेपर chances से अच्छे होने के, 25% chances से बुरे होने के. Now, by the time we'll be done, will be 10% chances बुरे होने के and 90% chances के अच्छे होने के, because हमारी तैयारी इतनी अच्छी हो जाएगी. On the other chance, if we spend a month studying on P4, this will stay at 25% and 75%. But this will also decrease our marks because we've had very little time spent on descriptive questions, right? Like writing an answer down, how to write it for the CIEs. And we've spent no time at all, at least in chemistry, I'm sure in biology and physics. So आप वो सारे P4 की training कर रहे होंगे, right? So you'll just waste a lot of time not studying, especially when I'm pretty sure at this point in time, chemistry is the topic you've covered the most syllabus in. And I think biology and physics are probably lagging behind because we ran through the syllabus and we had our extra classes every Friday. So if you ask me, paper 2 से आपके chances hurt हुए हैं? Yes, but आपके chances also improve हुए हैं. And paper 1 is you could have not asked for a better deal to score an A star or an A in your exams. So I say, don't worry about it. I think any news you'll get will always, because we're all in a state of anxiety and panic, will always conclude to the worst of decisions. I say this is the best thing that can happen to us right now, to the point where I'm actually disappointed and hurt and defeated because we spent so much time trying to improve our P2. Because that's what my plan was. पूरे साल हमने P2 के ऊपर focus किया, and or theory पे focus किया because And last 2 months मेरा plan था P2 और P1 के हम इतने questions करेंगे, we'll just turn our average C grade class का average C grade into an average high B or an A grade easily. But all my years worth of planning went to waste, so to speak, because not really, I guess, because my focus was to build a lot of understanding of basic chemistry, even if you couldn't perform it too well. But you weren't with us for throughout the year, but you're also feeling that effect because students around you you're asking for help and everything are in the same boat. And this is the best thing, honestly, that can happen to everyone. You have to worry about chemistry on June 8th. Your average subject load has gone away. You have lesser exams now. It's a win-win-win through all across the board. I say, honestly, don't worry about it. Be happy about it. I hope I made myself very clear. Be excited about this. आराम से कोई exam की tension नहीं होगी. By the end of May, I've gone through the process. I've taught 3 years of A levels and my first year of O levels. We'll have a lot less anxiety जब paper 1 के MCQs का time होगा, and we'll be just doing MCQs last 2 weeks, June वाला or late May वाला time, because you'll only have MCQs around that time. बहुत सुकून का time होगा. You'll be a lot less anxious. Your peak anxiety will be around 16th May के time. All right, bye-bye, guys. I hope this made sense. I hope you guys enjoyed the lecture. Bye-bye, take care. Bye-bye, guys.